Hi, I'm Riley Berton, Principal SRE at Major League Baseball. I'm here to talk to you today about incident management at Major League Baseball. We're going to go over the agenda really quick. I'm going to introduce Major League Baseball in case you're not familiar with what Major League Baseball is. I'm going to talk about the technology landscape inside Major League Baseball because it's a little bit more complex than you think. I'm going to talk about our particular alerting and incident problems that are sort of specific to Major League Baseball and other sports, I think, and then how we leverage PagerDuty to solve a lot of these problems. So if you don't know what Major League Baseball is, we are a professional baseball league, the world's premier professional baseball league. We represent 30 baseball teams across 27 cities, 19 states, and 2 countries, the US and Canada. Big technology fan, Major League Baseball. You can follow Major League Baseball on Twitter at MLB. I am at Riley Berton, just like my name, if you want to find me. Okay, the MLB technology landscape. The footprint is quite large. We have exposure to multiple clouds. We have exposure to multiple on-prem data centers. And when I say multiple, I mean lots of. And we have a huge pile of technology that we use in various places throughout our organization. The technology stack at MLB is surprisingly large, considering that we're a baseball company, not a technology company, but we're more of a technology company than you think. We have offices in New York City. We have offices in Denver. We have offices in San Francisco. We have data centers in New Jersey and Denver. These are physical data centers where we run hardware that cannot be cloudified. We have most of our exposure to the Google Cloud platform, some still remaining in AWS. And we do have some exposure to Oracle Cloud as well. And we have 30 little mini data centers at all 30 major league ballparks. We also have smaller data centers at minor league ballparks, but I'm not going to cover them for purposes of this talk. We have lots of technology. We're a big Kubernetes shop, big ActiveMQ user. Most of our stuff is in Java and Spring Boot, but we also have all this exposure to other stuff, lots of networking to tie all of these disparate things together. Lots of video processing and video equipment because we deliver a lot of live video to the world. So there's a lot of stuff inside the MLB umbrella to keep track of, right? And we have several constituencies that we serve. We serve all the ballparks or all the teams. This is video data for in-game player stuff. This is statistics about baseball. This is Wi-Fi. We run Wi-Fi in a lot of the parks for the teams. That's a service that we provide. We also provide data feeds for like pitch tracking and other things directly to cable and regional sports networks. So when you see the little pitch on the screen where the ball goes through the strike zone or not, that's provided by data that we're processing in real time. We also provide services directly to fans, right? So if you're a .tv subscriber and you watch baseball on your Roku or your PlayStation or your phone, right? That's something we provide direct, as well as sort of the MLB app, the ballpark app for ticketing, website information about baseball, right? So there's a lot of stuff going on to make all this function. And I say all this so that you understand the volume of stuff we're dealing with. So I'll talk a little bit about our specific alerting idiosyncrasies. A lot of this is common to general tech. A lot of it is specific to baseball or other sports, sort of seasonal sports leagues, right? Alerting generally falls into these categories where we have sort of traditional reachability style stuff where we're pinging devices to make sure they're up. But then we have a lot of SRE style sort of latency errors, the traditional SLO style alerting. We also have quite a bit of environmental alerts. So a lot of our equipment that runs in ballparks is temperature or humidity sensitive, right? So we need to keep track of that and sort of maybe power things down when we're having temperature issues. A lot of the parks aren't traditional data centers in the environmental control sense. They're sort of add-ons and they're in weird places in ballparks, and ballpark environment isn't always great. So that's very important to us. The network, as I mentioned earlier, is massive. It connects clouds and on-prem data centers in all kinds of tricky, interesting ways. So we need to keep track of that. We're also delivering MPLS video from these parks that goes to broadcast, right? So we need to know that the video delivery is working properly. And then we have the traditional infrastructure style alerting, right? Like the message queue is full, or there's too much RAM being consumed on some box, right? Or there's Kubernetes issues, or the disk is full, or whatever. So we have all this sort of alerting styles of alerts going on. We also have requirements for our alerts. Different teams want information in different ways. And this is probably common to a lot of organizations that are semi-large, but some teams want to know about everything. Some teams only want to get alerted if it's sort of an actionable thing. Some teams want to suppress alerts when they just don't care what's going on. And we'll get to that in detail in a little bit. And a lot of teams have different delivery requirements, right? They want it in Slack, or they want a phone call, or they want sent to this group email, which then they control where the delivery goes to, right? Or they want the traditional, push to their phone. So we have all these requirements going on. And the final requirement, which is special to baseball and probably other sports leagues, is that we need our alerts to be baseball schedule aware. This means that the teams are not always playing in their home park, right? So the Atlanta Braves will travel to New York to play the Mets. And while they're not playing at Truist Park in Atlanta, there can be alerts going off or problems happening with their ballpark that we don't necessarily care about so much because there's no live game going on, right? So we can sort of suppress them or maybe reduce the priority of those incidents that may be going on in those parks with hardware or software when they're not there. So this is an important requirement for a lot of the alerting and incident management that we do here at Baseball. So we have a very complex environment. I hope I've given you a feel for that. We have many, many, many interconnected services, both in software and hardware and network layer that all sort of pile on top of each other. Surfacing systemic issues is hard, right? Traditionally, the team that owns that service will get alerted, but it could be impacting other stuff, and other teams need to know what's going on because maybe it's impacting a thing that they own, and they have their own alerts going off, right? So, but getting everybody on the same page is a challenge in a complex environment of this size, right? So it boils down to this. It's really hard to know what's going on when things break, and this is probably a pretty common problem among PagerDuty users in general. So I'm going to talk about how we use PagerDuty to help solve these problems. So I arrived at Major League Baseball after a long and illustrious career in 2019, January of 2019. And PagerDuty was, I think, relatively recently adopted as a tool here at MLB, but it wasn't implemented in a great way. The teams were sort of given the tool and told you can go off and use it how you will. And without a sort of deep, broad understanding of the platform, a lot of them opted to just properly set up an escalation policy and a schedule. Those are good things, right? So they can manage their on-call. But also, they would just set up one technical service for the team, this sort of ball of mud where all their alerts would go. So you may have a team that was running 100 individual software services providing some portion of the stack of MLB's technology, but they'd have all their alerts arriving in sort of one ball of mud. And it was impossible to tell what was broken, really. You just know that that team is having an issue, but you'd have to go ask them sort of what was broken without sort of deep knowledge about the alerting that was going on, right? No inter-service dependencies were utilized at all. So, and that's still sort of true today, and I'll talk about that. There definitely was no business service utilization. I'll talk about that in detail in a bit. No status updates were applied to tickets or incidents so that we could have better communication. Nobody really used priority at all. So basically, it says it here on the bottom of the slide, but PagerDuty was just a message router, right? You had a monitoring system, it set off an alert, it would go to PagerDuty, PagerDuty would just do what the escalation policy said, and we weren't getting any value out of the platform after that, right? So quick refresher here. If you don't know what these things are inside PagerDuty, I'm going to go over them quickly. We're all familiar with what a technical service is. That's where we send our alerts. When we have an alert go off or we want to create an incident, we create it against a technical service. PagerDuty also supports this concept of business services. So a business service is something that models a business process or a grouping of technical services that make up a bigger idea. It's loosely defined, I think, on purpose because it's incredibly powerful. So I have a little diagram here of the Acme website, right? The Acme website here would be the business service, and then the user service and the cart service may be our technical services in our made-up example. An alert goes off to the user service and it impacts that business service, right? So people who are paying attention to the Acme website or care about that know that there is a problem. And we know further that the problem is in the user service and not the cart service. And that's an important thing to know. So where we want to get to is we want to get to democratization of the system status, right? All this siloed information, all these balls of mud make it really, really hard to know what's going on. And we want to let everybody know what's going on all the time. So if they're having their own issue, they can go consult something to figure out how it relates to the business of Major League Baseball, right? So we're going to utilize the PagerDuty status dashboard, which is something that comes along with business services here to perform this. So a lot of you may be familiar with statuses. You can even go to status.pagerduty.com right now and check out their public status page about how their system is operating. We want to do that same thing. We want to be able to provide that level of information internally, right? And then eventually externally too. That would be cool, but we're not there yet. It gives us one place to look to see what's going on. And further, interested parties or stakeholders or executives can subscribe to those business services and get sort of status updates about what's happening with their thing that they really, really care about in real time, which is fantastic. The alternative to which is them knowing which Slack room to joining that Slack room and sort of digging through all the conversation going on about an incident to figure out what's going on. It's a very difficult model that we have found. So this all sounds great. How do we get there? And we get there in 3 ... easy steps. We have to define the technical services. This is actually not that hard because the teams who created the balls of mud for their alerts to arrive at, they actually know what their technical services are because they operate them. So the team that has 100 technical services knows what those 100 technical services are because they write the code for them and they deploy them. So we just have to ask them, which is great. That part's easy. The definition of business services is a little bit more tricky. I keep going back and forth about this personally. We try to define them fine-grained enough to be useful, but not so fine-grained that they are basically just copies of technical services. So we tend to roll up, for an example, a ballpark in Major League Baseball may have 9 or 10 individual technical things going on, things related to the Wi-Fi or the network or services running in the software services running in the park or whatever. Right, we roll those up into a business service called Atlanta Braves, MLB Ballparks Atlanta Braves, so that we know the Atlanta Braves have an issue going on, and it's specific enough that we know it's only at the Braves ballpark. We also tend to roll these up in multiple ways, which is another powerful feature here. We can roll them up to the ballpark of Atlanta Braves, and we can roll them up to all ballparks. So anyone who wants a higher level view can know something's going on with a ballpark or some ballparks. And if they want to know specifically, they can see, okay, it's specific to the Braves, right? And you can see that example on this slide back here. We have MLB ballparks, and then we have, on the picture on the right, Cleveland Indians in this case was impacted. So the final step we need to do is we need to reroute all of our alerts. So our alerts for going to the balls of mud, we need to split these up and send them to each of the individual technical services. Now, this is a daunting issue because there are hundreds and hundreds of them. And that's no fun to click through the interface to try to create and reroute all of our monitoring tools to send to the right place, right? Now, we happen to be a fairly large Terraform shop. We're clearly going to use the PagerDuty API in some way to perform this task because it's rather daunting. We happen to be a Terraform shop. We use Terraform for most of our the infrastructure in general. So it makes sense for us to just leverage the tool we already have deep expertise in and apply the same concept to PagerDuty, right? So Terraform to the rescue. PagerDuty has their own provider for Terraform, which is fantastic. We can very simply define business services directly in code, and we keep this in a GitHub repo. And then anyone who needs to add a business service or modify a business service can go change the code, go through the pull request process. We commit it, we run Terraform, we have our change, right? So here's an example of a business service that I run called observability. I am the owner, right? It's tied to my team, observability. Very simple. We have a business service defined. That business service is made up of multiple technical services. Technical services are a little bit more complicated. We define these with a module because the definition of a technical service has all kinds of stuff that comes with it, right? You have not just the tie to the business service, observability in this case, and the name of it, APM server in this case, but you also have event rules that may exist with that service and other sort of configuration about how alerting is handled for that particular service. And we want to hide this. We want to make this as easy as possible for people to come in here and define their technical services for their team. So we hide all that complicated abstraction behind a module. And we basically ask them to define a couple of things. One is the name of the team, who owns it. Seems reasonable. One is the escalation policy that is at play for that team. So this forces them to define an escalation policy, which is a great practice. They have to name the service. It makes sense. And they have to tie it to one or more business services or zero. But in general, we like them to tie it to a business service so we can have good visibility over it. The other thing that this module provides is Slack integration. I'll go over that in a bit. It's a difficult thing to Terraform directly. Great. So now we have business services defined. And here's an example of a few that show up in the PagerDuty interface. We have one of these for each ballpark. We have this for network stuff. We have this for observability, as you saw. Great. So now we've defined technical services in a way that's scalable and sustainable. We have defined business services, right? We have to reroute our alerts. And this is the tricky part. But before I do that, quick aside back to baseball schedule awareness. Remember, we have this issue in baseball and a lot of sports leagues that people aren't always playing in their park. There are things we want to shut off. Some technology is 24/7, like the website. Some technology is only during live games anywhere. Some technology is only during live games at a particular park, right? So you're probably asking, there's a feature inside PagerDuty called maintenance windows. Why don't you just use maintenance windows? Well, it turns out that this is hard. Managing that many maintenance windows is a challenge. We're actually mostly maintenance window and sometimes off because the games are only a couple of hours. So that's one challenge. We'd have to have multiple different types of overlapping maintenance windows to make this work. And then we have weird stuff that happens like weather and recent history, pandemics, where it can rain and a game can get postponed. Changing the maintenance window, it's another thing to have to try to sync up. And then famously, well, I think famously, but the Mets opening day series was canceled because the Nationals had too many COVID positive tests at the time. So out of safety, we canceled the series. So that affects everything, right? We don't need the alerts going off at the Washington Nationals Park because there's no game. And that the schedule just sort of changed out from under us at the last minute. So that kind of stuff is difficult to manage using the API or Terraform with maintenance windows. We have to constantly be running it and keeping track of the schedule. So instead of doing this, we have a piece of technology that sits between our monitoring system, Zirconis in this case, and PagerDuty that sort of applies these rules in real time. So when we define alerting, we define it with instructions about what to do with baseball schedules, right? And then when an alert comes in, our little component in the middle there called Pacitea can reach out and consult the baseball schedule, see if there's a game being played, and then either suppress the alert or send it on to PagerDuty. And then it also acts as a webhook, and this is where the Slack integration comes in. We have webhooks that come back out of PagerDuty to the same component, which then manage the Slack integration. Unfortunately, today in PagerDuty, you can't very easily Terraform Slack integrations because they require a manual authorization for each room I try to set up. So we opted for a different approach here. So this is how we Terraform alerts. We Terraform them in the exact same repo. We Terraform everything else, and we tie it there in bold directly to the contact group. that was set up, which represents the PagerDuty technical service, right? We also allow people to put schedule awareness directly in their configuration. This is all done in one spot. They can say, hey, this needs to be schedule aware for this particular park or any park or whatever. Suppress the alert if there's no game going on. And then we get it in Slack. The link at the top will take you to PagerDuty. The link in the middle there to Grafana will take you to our own internal visualization tool. And we've done it. We have, I guess, profited from all of our setup, except we're not all the way there. So what's next for Major League Baseball on incident management? We want to reduce our MTTR. What we're not doing well today is we're not mapping technical service dependencies to other technical services, right? Which is an extreme value add for reducing how long it takes to diagnose an incident. So we want to get a lot better at that. We're gathering data to get better at that today. And we also have a lot of work to do on our best practices around here. Incident commanders, status updates, postmortems on all major incidents. And eventually we want to get to a public status page, which is the culmination of all this work and will reduce the impact on our support team and hopefully make customers a lot happier because they'll know what's going on. And that's all I got. Thank you. I hope you guys enjoy the rest of the summit.